Hi, everybody. As you heard, I'm Joel Kin, and we're going to talk about building custom UI with UIKit. Now, ordinarily, on a big stage like this, I'd be walking up and down to show how relaxed and casual I am, but there's only light right here, so I'm going to be unrelaxed and uncasual directly behind this podium. So, quick agenda. What are we talking about here? We're going to talk about, in broad terms, the problem that it is we're trying to solve. And we're going to look at an example of that problem, dive down into the code required to solve it, then we'll go back up to the high level for some takeaways. That's about it, so let's dive right in. So this is a quote from me. I'm quoting myself. I couldn't find an inspirational quote from somebody else that applied to this situation, certainly not from someone famous, so this is what you got. So what we are really talking about here is the joy that you feel when you find what you need on GitHub versus the sinking feeling you get at the pit of your stomach when you go into somebody else's code base, and they've done a lot of that. Now, to be clear, third-party libraries do have a lot of advantages. They're convenient, and they're easy to integrate. However, they are also built to someone else's product requirements, which means that once you need to go beyond out-of-the-box functionality, well, congratulations, you're a core contributor. This can be a reasonable trade-off, but as Apple's frameworks become more powerful, there are fewer and fewer occasions when that makes sense. So let's get a little more specific. We typically use a third-party library when we're short on time and we're trying to build something complex. But we don't always consider the potential disadvantages that come with it. Third-party code often makes different trade-offs than you yourself might do. It was primarily built to somebody else's needs, which means that if it's flexible enough to do exactly what you need to, it's probably more complicated than you'd like. There's no guarantee that the original author will update it for new OS versions, so that responsibility might fall on you as well. It might not do some of the things that we should be asking for, even if we don't always remember them. And there are technical dangers involved in introducing third-party code to your codebase, ranging from impossible to debug swizzling conflicts to malware potentially stealing user data. All that said, I'm not here today to convince you that these downsides are bad things. I think we're all experienced enough in this room to have been bitten by one or more of the things on this list. And if you haven't, please find me afterwards and tell me your secrets. So instead of breaking down the bad things here, I'm going to try to demonstrate that even the advantages don't really pan out. We're going to look at one example of a complicated component that we might need to build and see if we can't do it in about as much time as it would take to find and customize an appropriate third-party library. And because we're going to write it ourselves, it'll be just what we need, no more, no less. So let's say your designer asks for a slide-to-unlock control that's styled like iOS 13. And the closest example is probably this slide-to-power-off control. It looks complicated, right? But take a minute and observe what it's really doing. It's, in fact, a collection of behaviors, each one of which individually is pretty simple. So we'll break it down into its constituent elements and see what's really required. Now, this is just one possibility, so bear in mind that we're trying to apply general principles here. You can do this for any custom control or, in fact, any product element. That said, we need to ask ourselves, first, what are the requirements? And then, what tools do we have to get us there? Now, these are the product requirements that are clear from the design, hence explicit. We need a slider, basically, where the user can move a thing left and right with their finger. We need to be able to customize how it looks and behaves, in particular making it snap back to the start on release. And we need some shimmery text. But there are also the requirements that we as conscientious engineers know we ought to add. The average designer might not be thinking about designing for Arabic, but that doesn't mean that we can't think about it. Similarly, building for accessibility is always the right thing to do, and it might even help if you want to get featured. Here comes the hard part. What is our foundation to build on top of? Well, CA layer is the lowest level graphical abstraction in the system, unless we were to build this in Metal, and I don't think that's a great idea. UI view adds simplified touch handling and lifecycle events on top of CA layer, but it's still basically just a rectangle that doesn't know how to do that much. UI control is Apple's medium-level abstraction for controls, so now we're getting to something that's specific to our needs. We could go directly to UI slider, which is kind of the same shape as what we're trying to make, or we could type slide to unlock into GitHub and go to town. So we're going to ignore the UI control option because it's pretty well superseded by UI slider. And the same thing goes for building directly on top of UI view or CA layer. We can get more of the things that we do want without accepting a lot of things that we don't. Well, that's an easy decision. That means we're left to choose between UI slider and a third-party library. Here's my comparison of those things, as unbiased as I was capable of, although obviously I do have a bias, that's why I'm up here. I won't discuss the specific GitHub library that I was analyzing too much, because I'm not here to call anyone out, and this is not about any specific control. This is about the mindset, not the specific implementation that we're looking at. But as we can see, we don't actually have an obvious winner here. No matter what we choose to build on, we're going to have to implement some things on our own. So the question is, would we prefer to build on top of Apple's component? And again, I'm standing up here. I would argue that we should. That means looking at what's missing here, we're going to need to customize the track and the thumb, and we're going to need to add support for snapback, and we're definitely going to need to deal with that shimmery text. OK, well, let's see some code to do that. Here's our V0. It's pretty good, right? It has a track and a thumb, and it moves when you touch it. I'm being a little bit tongue-in-cheek describing this, but it's worth recognizing just how many of our core requirements we're meeting without writing any code. If we were really working on an MVP app, this could actually ship as a slide to unlock control. You'd maybe want to put some text on either side of it and subscribe to its value changed action to see when it gets to the end. It's got built-in voiceover support, and it knows how to reverse direction for right-to-left languages. Really, this is not a bad solution for 0 lines of code. But when we leverage the built-in customization points, things get dramatically better really quickly. This doesn't look like it's quite ready to ship, but it does look like it's 80% of the way to the right appearance in about 20 lines of code. Here's what's happening. We define the intrinsic content size to be the predefined height for the component. That's just the dimension that our designer gave us. And this will give auto layout a hint as to how to size the component. UI slider gives us hooks to calculate the size of the track, so we're just going to use our intrinsic content height and center it within whatever frame we're given. This way, the shape of the component won't get distorted. We do the same thing with the thumb, resizing it to fit our thumb image and centering it in the middle of the track. And finally, we just round the corners to get that round rect look, and we set the thumb image our designer gave us. Or in this case, that we made ourselves in Sketch with the flag emoji. If the question is, should coders design, I think obviously the answer is yes. Yes, we should. Now let's add some behavior. At this point, another 15 lines of code in, we have 80% of the look and maybe 95% of the feel of the finished component. So let's look at those 15 lines. First, we'll add that snapback, where if a user lets go of the thumb and we're less than 3/4 of the way to the end of the track, we'll animate it sending it back to the start. Otherwise, we'll send it to the end. We'll also send an explicit action when the thumb hits the end. We could say that users of our component should just use value changed, but this is a nice enhancement, so they can just think about the binary value. Technically, though, it's not even necessary. Now let's put some text under the slider. And it's really looking decent now. All we do here is provide an API to set a title, and internally put that into a label that we position on the track. It's lucky for us that a new sublayer will be added above the track and below the thumb. But if that weren't already the case, the way UI slider works, we could change it just by changing the label Z position or using insert at index rather than add sublayer. Hiding the text as the slider passes requires just a bit of core animation trickery. Another 10 lines of code gets us to maybe 90% of the appearance we're looking for, and it really seems pretty sophisticated. So this is the core of the work that's happening. And it looks pretty hairy, but all we're really doing is using the contents rect property of the label to tell it to render less than its whole width. In case you haven't dealt with this in core animation before, contents_rect is a rectangle describing the renderable area of a layer. By default, it's the unit rectangle, a 1x1 square, which represents the entirety of the layer. We're shortening that rectangle by the amount that the slider has moved across the track. We have to do a little bit of weird math here because the thumb position doesn't go all the way from one end of the track to the other because it has its own width and it has a margin on top of that. So we have to take that into account when figuring out exactly where to stop drawing the text. You'll also see that we're using the intrinsic content height again as a constant here to position the label because we know that that number is used in the calculation of the corner radius. So all that adds up to this code looking a bit odd, but conceptually, we're just saying truncate your rendering by the amount that the slider has moved. Of course, to get this looking really fancy, we need to add the shimmer effect. I'll point out first that this provides us with a chance to use some more system functionality. We can hook into the control's tint color and make that the color of our text. This means that the user of this API can theme the component as needed using the same system hooks as for any other UIKit component. UI appearance would work here too. So we're going to do the shimmer in 2 steps. First, we'll build a gradient layer. This is a fair amount of boilerplate, but it's just setting up a gradient that looks like a spectral highlight. That means there's a blurred out white section in the middle of the gradient, like when you look at shiny metal under the sun. Then we'll set up an animation for that gradient. This will move it from one end of the control to the other, repeating forever. We're animating the gradient's x position, repeating infinitely, and moving from the far left to the far right of the component, which you can see in the from and to values. All we have to do after that is put a mask on the containing layer. We'll use the label itself, which means that we're seeing the animating gradient through the text, rather than just seeing the gradient. Now let's test with the right-to-left pseudo-language. Well, almost there. But because we set up the thumb rect based on the value of the slider, 0 to 1, rather than by referencing super.thumbRect, we'll need to change that math manually to account for a different direction. We'll also have to do a little work to make the text disappear from the other side. I said that we'd get internationalization for free, but I was just a little bit untruthful. We have to do a bit of work for it because of some implementations choices I made, mostly to fit code on the slides here. The good news is that UIKit gives us all the building blocks we need to do that. So we first need to know whether or not we're in a right-to-left world. That's easy enough. This is UIKit's slightly verbose way of figuring that out. Then we change a couple of things, basically flipping 0 to 1 or 1 to -1 based on that fact. We'll flip the thumb rect start and finish points by putting the 1 value on the left rather than on the right. And because it's easy, we'll make the shine animation go backwards simply by reversing its speed. Now, these are literally one-line changes, so it's not quite free, but it's the next best thing. The last piece is to fix the label's contents_rect. The math here is a bit more involved, just like before, but conceptually, we're just truncating from the right instead of from the left. So really, the only hard part for internationalization is figuring out 2 different cases for that complicated math problem, rather than just one. So let's take a look at this in real life. Great. So here's our simulator running the real component. It behaves as advertised. Pretty cool. But I'm more interested in talking about the code here, I think. The code and the interface builder accommodations in particular. So first, I'll just point out, this whole thing is only about 160 lines with comments in there. So really not a whole lot is going on here to make a pretty sophisticated control. You'll notice that we have a preview in Interface Builder, and we even have editable attributes so that the user of this API can do their work in Interface Builder if that's how they prefer to work. So we're going to quickly go back to the simulator and start thinking about what the accessibility story might look like here. So Here we have our accessibility inspector, which does have a bad habit of losing its context. So I'm going to rerun here. And I ideally would go to a real device and do a whole voiceover demo, but I don't want to deal with switching between different devices. So we're going to forego that. Instead, we'll look at the accessibility inspector, which, in a world in which it works, would give us something to look at here, which would be the same thing that a voiceover user would have access to. There we go. Works like magic every time. OK, so as we can see here, the first thing I want to point out is that the label of this accessibility element is the same thing as the title that we set. In order to make that label visible to VoiceOver here, instead of just an empty string, it's a one-line change. All we have to do is set the accessibility label at the same time that we set our title. What we get for free, though, because we're based on UI slider, is these increment and decrement actions. So using this and only this, a VoiceOver user would be able to use the component exactly the same as it's intended. However, with another 3-line change, we can add this all-in-one perform action, which takes the slider all the way to the end. So it's important to point out here that from our v0, from just plain the UI slider, we have a perfectly reasonable accessibility story. There are small changes that we can do to make it better, to make it easier to use and more pleasant, but it works without any additional code whatsoever. So to demonstrate that there's no rabbits up my sleeves, I'd like to just go through this whole code briefly, and we can point out what we've been talking about. So almost everything in here is exactly the same as we saw in the slides, and I'll just make a note of it where it's not. So we have our unlock slider, which is based on a UI slider. It is, of course, IB designable so that we can get this interface builder preview, which I will now get rid of for more room here. Setting our title is the same as we saw in the slides, with the addition of setting the accessibility label as well. And that's why we get that nice little call out in the label in the accessibility inspector. We set our thumb image a little bit differently, but this is just a pass-through to UI Slider's own thumb image and set thumb image. The only reason I do this differently than in the slides, where I just do a set thumb image with an image literal, is so that, again, we can have that interface builder accessibility. Creating the shimmer effect is exactly the same as it was in the slides. So we use the tint color of the component to set the color of the text. That's what's going to show through when the gradient is not present, because the text is used as a mask. We create a highlight gradient, which goes from clear to white, and then white to clear. That's where our specular highlight comes from. It's in the horizontal direction, because its start and end are at x is 0 and x is 1. We create that shine animation that we talked about, which moves the positions x for an infinite number of times from before to after the bounds of the component. And we decide which direction it's going to move if we're in a right to left versus a left to right world. Again, our label is the mask of that gradient. And that's it. That's all it takes to make a cool little shimmer layer. We create our label exactly as we saw in the slides. Nothing magic here. It's just a UI label. We determine whether we're right to left, as we saw in the slides. We've seen almost all of the lines from setup, but we haven't seen them all together. What's new here is that we're clearing out the minimum and maximum track tint color in favor of our own background color. And this is purely because we don't want to have different colors before and after the slider on the track. We set up our corner radius for our round rect, and instead of adding the label, we add the shine layer for the shimmer effect to be directly in the view hierarchy. And of course, we add our actions for touch-up so that we can snap back. Layout subviews, again, we've seen all of these components, but we haven't seen them all in the same place. So very briefly, we find the bounds of our track, and we set that to be the same size as our shimmer layer, so that it will fill the entire view. And then we do our complicated math to determine where the text should truncate if we're in a right to left or left to right world. We have a prepare for interface builder purely so that we see something going on here rather than The thumb is all the way at the end, and nothing exciting is happening. So you'll see that we set the begin time of the shine layer here. Sometimes when Interface Builder is feeling right, you'll see some gradient here, but sometimes you won't. And that's just the way it goes. This is one of those days. Our init methods don't do anything special. They just call into our setup. And now we get into the styling overrides. And this is what we were looking at the V1 slide, the one right after the bare UI slider. The only thing new here is that we override setting the tint color so that we can change the text color even after the component is on screen. The intrinsic content size is just setting the constant that we were given by a designer. We calculate the track rect, centering that intrinsic content height within the frame that we're given. And we do our same math for the thumb rect, sizing it to the image and centering it on the track. So the part that we didn't see on the slide addressing this was determining whether, if we're right to left, the value is going to be on the other side, which essentially just makes the thumb go backwards. Moving down to our behavior section, we really have very little going on here. So we override set value purely so that we can send that binary action for when the slider has reached the end. Again, this is not necessary, just a nice to have. We have our fun snapback behavior, where if the value is more than 3/4, we go to the end, otherwise we go back to the start. The only difference here between the slides and what you're seeing is on the slides I used a basic animation because it fit better. Here I use a spring animation because it looks better. And this is our 3-line change to get that activate button in the accessibility inspector so that a voiceover user can just say activate to go all the way to the end instead of saying increment, 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 OK. And that's it. That's all of the code here. And now you understand it as well as I do. So let's go back to slides. So this is just one example of how UIKit makes building quite complex controls pretty easy. Starting from a strong foundation means that there's less to build yourself, and that applies double to things we don't always think about, like accessibility and internationalization. Building components from scratch also takes just about as long as it does to find and customize the right third-party library, but it means that you're in control of the compromises you make. The important thing to take away here is not this particular slide to unlock component, but the concepts. I want you to take away the knowledge that you can do this in as much time as it takes to find the right package and customize it to your needs. And I want you to take away the framework to help make your decision, to first enumerate both the explicit and implicit product requirements, and then to compare and contrast what foundation would work best to achieve those requirements. The full code is available here if you want to take a look, but hopefully you'll be less inclined to include it in your own projects after this talk. To that end, it's not packaged as a Swift PM or Carthage library. It's just up there for your inspiration. That's it. Thank you for your time.
Thank you, Joel. Can you please join us here? I told you we would not have only Swift UI code. So
right.
I'm happy to see.
I'm old school.
But I'm happy to see some interface builder windows on this big screen.
Yeah, some UIKit as well.
Yeah, it reminds me, especially with IB inspectable.
Well, I don't get to use them at work, so it's a delight and a pleasure to bring it up here.
How much time did you spend polishing the UI? And because usually it's like taking a lot of time.
Yeah, well, that's a good question. So I didn't actually spend that much time on polish because I just picked some values that I thought would look good enough. So if I were actually working with a designer who had a very specific vision of what they wanted, then probably there would be some more back and forth on, is this slide animation quite right, things like that. But for the purposes of a demo, kind of default values turned out to work pretty well.
Yeah, but it looks quite good. It looks
Thank you.
Really production ready. So it's like, interesting to see that you can achieve this goal starting from real components provided by Apple. But I was wondering if it's not okay. You can do that this way, or you can go from scratch and write everything. That would be much more complex. But what do you think about the maintainability of that? If Apple would change some behaviors of the slider, it would break easily the component? What do you think about that?
Well, that's always a risk. But I think the greater risk is that the design language in the Apple world changes, as happened with iOS 6 to 7, and then your completely scratch-made custom component feels totally behind. So from my point of view, the advantages that you get from building on top of first-party components, which is like when they add new accessibility interfaces or new localizations, you get that for free. If you make your thing from scratch, yeah, no one else is going to break you, but also no one else is going to save you.
Yeah. So looking at that UI kit code, in a way, it looked like, at least to me, that at least if compared to SwiftUI, of course, that UI kit was more mature when it came out. In
No
a way.
comment.
When it came out,
Well, when it came out. Yeah.
because now it's obvious.
Was it the case, or actually it was like, since you worked with it from day zero, like there are lots of rough edges?
That's an insider question.
There are a lot of definitions for when it came out, so I would say that on some of them, yes, and on some of them, no. Certainly when it was first available for internal use, it was a hot mess. But I think that we tend to shrink our memories as we look back. It's easy to forget how rough things were in like the iOS 2 era or the iPhone OS 2 era, and how long it took to get like best practices and good documentation and many dub sessions before everybody really had a lock on how this stuff worked.
And we were talking about tests this morning. And how would you go for testing that approach?
Great question. Certainly, snapshot tests would be the way to go. So
Now I know.
not totally a joke. So you might think that because there's animation involved in that component that a snapshot would be difficult or inappropriate, but actually the secret was in there. If you set the speed of the layer to 0 and set some time offset such that you have the gradient at some like known place on the screen, that's a predictable snapshot, and you can reuse that forever.
Yeah, and you can actually simulate some, not just set some states programmatically, but simulate the user interaction that
Absolutely.
would go quite far.
Right.
Okay.
A question from the audience. How long is how long was the GitHub? How many lines of code had the GitHub implementation compared to yours? If you
Lots
remember?
more.
Lots more.
Yeah.
I don't remember for sure, but certainly 3 or 4 times the size of mine. I mean, you just get a lot for free when you're building on top of what's already there.
Yeah, and there's also one point that you could have mentioned. Is it's much. Usually, people really like doing that from scratch. And as you were saying, when you have a designer, then you can go really deeper into the integration and what you want to do exactly. But when you start from Apple components, can you do also deep customization?
Sure. Well, you can always do as much work as you have time for, essentially. So I think what you get from starting with Apple components is there's a really strong foundation to build on, as I was saying, and most of the things that you want are going to be there. But that doesn't mean that you have to use them. You can always say, oh, well, I don't like this behavior, so I'll override method X, Y, and Z and just do my own thing. And generally speaking, the APIs are designed such that you can do that for certain parts that you care about while still getting all the benefits from everything else. And that's really the sweet spot.
Yeah, yeah. I think. Yeah. Do you want to?
No, it's perfect. Sorry.
Yeah, I think we're good. Thank you very much for this talk.
My pleasure.
And thank you.